right, we're going to do a little bit of simplifying radicals practice, and I'm going to teach this as though you haven't seen it before, although since this is aimed at Algebra 1, you may have seen this in pre-algebra, but maybe not. So here we go. We simplify square roots in a similar way-ish to how we simplify fractions, as in there is an accepted method and an accepted end result that we like. So for instance, when you have a fraction, right? If you have 4/8, you don't leave it as 4/8, you change it to a half. With square roots, our goal is to take the square root if possible, if it works out to be a nice number. For instance, the square root of 36 on number 2 here is 6 because 36 is made up of 6 times 6. And a square root is asking, hey, what times what gives you this number where they're the same number? So if we can take the square root, we do. Square root of 36 is 6. But these other 5 that are on the screen right now are not perfect squares like 36 is, so they don't have a nice whole number square root. So instead of getting on our calculator and getting the decimal, what we do is we say, just because this number can't be square rooted, because it's not a perfect square, doesn't mean that it might not contain perfect squares. So the idea is to think of what multiplies to get this number, where hopefully one of the two things that we think of is a perfect square. So 20 is a great example for this because there's only a couple things you can think of that multiply to get 20. One of them is 4 and 5, and that's helpful because the square root of 20 is the same as saying square root of 4 times square root of 5. And so if we're able to split it up like this, which we are, then we can take the square root of 4, which gives us 2, and then next to it we just leave the square root of 5 because square root of 5 not only does not square root evenly, but also is a prime number and doesn't have anything else in it that we could possibly square root without resorting to our calculator. So square root of 20 simplified is 2 square roots of 5. So here's our goal with radicals, is that which is another name for square roots, is that we are trying to look at the number and say, is there perfect squares that I can take out? Now, that can be really tricky because if we're not super good at like thinking of factors, then it might take us a while to come up with the right factors to use. For instance, 32, you might be thinking is 4 times 8, which is in fact helpful because you can square root 4, but you also would have to then mess with 8. So what I'm saying is if we make the square root of 4 and square root of 8, that's great. That rhymed. Square root of 4 is 2, but square root of 8 actually can also split up into square root of 2 and square root of 4. And then we can take the square root of the 4 and get another 2. So what we have is a 2 and a 2, not underneath a square root. And then we still have this square root of 2 left under. And so what we do with that is we take the 2's that we got from our square root of 4's and we multiply them together. And then we take the square root of 2 and leave it on the inside. And then multiply those two 2's outside together and get 4 square roots of 2. Now, for someone just kind of starting this, I feel like this is kind of a confusing way of doing things and that there's actually a simpler way until you feel more confident about what you're doing. So here's how we do this. We make a factor tree for 32. So when we make a factor tree for 32, we start with whatever two numbers we can think of that multiply to get 32. It does not matter which ones you pick, so we can still pick 4 and 8 if we want to. But we keep breaking it up until we end up with all prime numbers. And remember that prime means that only one times that number ends up being factors. So now we're looking at the bottom of our branches here at these prime numbers. And we're going to basically pair up numbers that are the same. They don't have to be next to each other. We're going to pair them up, and every time we have a pair, that tells us that we've got a perfect square. Because if we have two 2's here, that's really a 4, and square root of 4 is 2. So I have a pair of 2's here, I have a pair of 2's here. And so for each of those pairs of 2's, we put a 2 outside of our square root. And then we look and see, is there anything left over that didn't pair up, which is this 2 right here in the middle. And so we got the same thing, which is good. It shows that both of these methods work. But because we have two 2's outside, we do multiply them together and say that's 4 square roots of 2. If you type square root of 32 into a calculator and you type 4 square roots of 2 into a calculator, they should both be the same like decimal number. So that's a way you can kind of check your answer, by the way, as you go along. So I'm gonna do more with this whole factor tree thing because I think that typically in Algebra 1, this is the way this is gonna make sense. And then later on, once you are feeling more confident, you can try looking for the perfect squares. So for 72, this one's kind of a big number. So I'm thinking 8 and 9, and then 8 splits to 2 and 4, 4 splits to 2 and 2, 9 splits to 3 and 3. So I'm gonna highlight this just because we're gonna ignore the numbers that aren't prime numbers and just look at the very bottom of our tree. Now, we are looking for pairs of numbers. Those pairs of numbers represent a perfect square that we can square root. So a pair of 3's means I have 9, and the square root of 9 is 3. So I get to put a 3 down without a square root over it. And then a pair of 2's. It does not matter which 2's you choose to pair up. Okay, so I could choose these 2's, or I could, whatever combination I wanted, but I have to pair up like numbers. So a pair of 2's also puts a 2 on the outside, because that'd be 4, square root of 4 is 2. But we've got a 2 left over here that has to stay underneath the square root. I have a really terrible analogy that I like to make with radicals that I realize it's a really terrible analogy, but I like to think of square roots as a prison, where in order to escape prison, you have to have an accomplice. So the fact that we have a pair of 3's, and it's also a really sad story. We have a pair of 3's, but only one 3 actually escapes. We have a pair of 2's, they work together to escape the radical, one of the 2's escapes. But this 2 that didn't have a friend to try to escape with, they get stuck inside. And then just, if we end up with more than one number, either outside or inside, we multiply it together. So that's why it's 6 square roots of 2. I know that it's a terrible analogy, but basically there are only certain ways that we can take numbers outside of a square root or put numbers in a square root. And so, I don't know, the prison analogy, I feel like makes sense, even if it's kind of a sad analogy. All right, let's look at 5. So 98, that's a really big number. Remember that if a number's even, 2 has to go into it. Hopefully you're not too terrible at dividing 2 into things. So 2 into 9 is 4 times with 1 left over. So 2 into 18 is 9. Now, if we notice 49 is a perfect square, we might actually get the answer a little bit quicker even. But we're looking for our pairs of numbers. So we have a pair of 7's that puts a 7 on the outside. We have a 2 left over to go on the inside. So that's 7 square roots of 2. I'm going to keep going with this, but at some point you should definitely pause and try it on your own. But just in case, I know there's at least one situation that hasn't happened to us yet that I want to address. So I'm going to keep going, but definitely pause and work ahead and see if you are getting the hang of this. So let's see. 54, I think of 6 and 9, which is 2 and 3 and 3 and 3. So we've got 2, 3, 3, 3. Our pair that we have here is the 3's. We have a pair of 3's. So a 3 gets to go on the outside. But 2 and 3 aren't the same number. So for whatever reason in our prison analogy for radicals, 2 and 3 can't get along. They can't cooperate. So neither of them get to escape. They both have to go inside. So this is what hasn't happened to us yet on today's walkthrough, is that if you have 2 numbers left that didn't pair up, or even more than that, you would multiply those together again underneath the square root. You wouldn't leave it as 2 times 3 or put them next to each other like 23. We'd say, okay, the 2 and the 3 that are still under the radical turn back into a 6. So this is 3 square roots of 6. If you're kind of interested in trying the other way, which is a little bit less work if you can get the hang of it, if you thought of 6 and 9 and thought, hey, I can square root 9, that would give us 3 on the outside, and then the square root of 6 stays square root of 6. So that's how that works. Okay, do a couple more. Let's see, 7, square root of 16. It can be easy to forget to just check to see if it's a perfect square. We know the square root of 16 because we know two numbers that multiply together to get 16 that are the same. So this ends up being 4. If you were not paying attention and did a factor tree, that sounds negative, but I don't mean it negatively, because you get in the zone, right, of doing the same thing over and over again, and sometimes we forget to check for things like perfect squares. Then we have a pair of 2's and a pair of 2's, and we don't have any single numbers left over, so there shouldn't be a square root at all. We should have 2 times 2, which is 4. So especially if you end up with big numbers that you don't know the square root of, then a factor tree actually can help you realize, oh, that's a perfect square. Okay, I think the last one I'm going to do is this one, 28. So let's make a factor tree. And let's say, what are our pairs of numbers? We have a pair of 2's. And then our 7 is left over. So this would be 2 square roots of 7. I just realized I want to show something else. So let me see if I can make that happen on this next one. I know I said it was my last one, but this one's my last one, for real. So I've got 2 times 100 would be one way of going about it. 10 times 10, 2 times 5, 2 times 5. Okay, so let's look at our numbers. What I wanted to point out here is the way I made my factor tree. I wanted to show you that all that matters is that we have a pair. They don't have to be next to each other. So for instance, we have a pair of 5's, even if I have to, in order to circle them, I have to be a little creative. There are 2 5's here at the bottom of my tree, so I can put a 5 down outside. There is a pair of 2's. Again, it doesn't matter which 2's you pair up. Just pair up 2 of the 2's, whatever's easiest. And then we have a 2 left over that goes back on the inside. So 5 times 2 is 10. This would be 10 square roots of 2. And with your factor tree, if you had noticed, hey, 10 and 10, that means that I have a perfect square. You can stop there and say, okay, I have a pair of 10's. Let me put that 10 on the outside. So that's an option as well. So hopefully this helps you with simplifying radicals. This is something that we are going to use in Algebra 1, Geometry, Algebra 2, and so on. So it is a good skill to have and to work on developing. Thanks so much for watching. If you don't mind, give me a like and subscribe if you haven't already, and I'll see you in another video.